Okay, this is exercise 9.3, question 16. The question says, show that the line y equals 2x plus 6 cuts the parabola y equals x squared plus 3 in 2 points. Now, if you want to show whether two lines intersect, you're going to have to solve them simultaneously, of course. So I've labelled each one 1 and 2, and because they're both equal to y, I'm going to use the substitution method, and I'm going to equate equation 1 and equation 2. That simply means I'm going to let 2x plus 6 equal to x squared plus 3. Okay. Now, what I'm going to do is I'm going to get all the terms on one side, so I'm going to start with x squared plus 3. I'm going to take away the 2x, take away the 6, and then I've got it equal to 0. Okay, we're going to clean this up so it becomes a nice quadratic. You get x squared minus 2x minus 3 equals 0. Right, now this quadratic, we could use the factor method to find the roots, and if we find two roots, then we can prove that the parabola, is cut by the line in 2 points. But there is a shorter way to do it, and that's using the discriminant. If we find that discriminant is greater than 0, then we've proven that the line actually cuts the parabola at 2 points. Okay, so the discriminant is greater than 0 if there are two roots, and therefore that means there's going to be 2 points where the two lines intersect. So let's find the discriminant. The discriminant is b squared, so minus 2 squared, move that up, 2 squared, minus 4 times a, which is 1, times c, which is minus 3. Okay, and we get 4 minus 4 times minus 3 is plus 12. That's 16. So therefore the discriminant is greater than 0, right? And hence the line cuts the parabola at 2 points. Okay. It simply means you're going to get two solutions, all right? If you get two solutions, that means you're going to get 2 points of intersection, all right? 2x values means you have to go looking for two y values by substituting back into here, as you used to do, okay? So this is a quick way of finding out whether the line cuts the parabola at 2 points or 1 point or no points. Okay, let's look at let's have a look here. 17. Question 17 is the same as question 16 to show the same thing, that the discriminant is greater than 0. Question 18 says, show that the line y equals minus x minus 4 does not touch the parabola y equals x squared. Does not touch. So if it doesn't touch, that means you're going to have the discriminant going to be less than 0. Right, because you know that when the discriminant is less than 0, there are no real roots. Okay, look at the sheet or look at the page of facts that I gave you on the discriminant, and you will see that's the case. So when you get to do question 18 and you get to this point where you have a parabola, then you would write discriminant less than 0, okay, for no real roots, and then do your substitution and show that you're going to get a negative number, and then conclude that discriminant is less than 0, hence the line does not cut the parabola at all. Okay, now let's do, now question 19, it says show that the line y equals 5x minus 2 is a tangent to the parabola. So if it's a tangent to the parabola, you know that that line is going to hit that parabola only at 1 point. And if it hits the parabola at 1 point, that means that when you get to the discriminant, for one real root, you know the discriminant is equal to 0. Okay? For one real root. Okay, so you're going to do the same thing as we did up here. When you get to this point, find your discriminant. It's got to be equal to 0 for one real root. Find it. Make sure that you do get equal to 0. If you don't, you've made a mistake somewhere in your calculations, right? If the question says show that this is the case, then it will be the case. Okay, you can't show otherwise. And then conclude, just like we did there. All right? So now, question 20. So I'll turn my page. Question 20 of exercise, question 20, says that the line, so I'll just put down this is question 20, the line y equals 3x minus p plus 1, okay, is a tangent to the parabola. It's a tangent, okay? That's an important word because a tangent tells you that you're looking for one root, okay? So you've got to think of discriminant. For one root, discriminant's equal to 0. So I would, as I'm reading the question, I'm putting these things in, okay? I'm just writing these things down because they're key points to help you solve the question. So the question says, let's go back and we just keep reading it, right? The line y equals 3x minus p plus 1 is a tangent to the parabola y equals x squared. Okay, evaluate p. We need to find p, all right? Now, if it's a tangent, what do we say? That the discriminant was equal to 0. So first of all, let's begin as though we are solving these two equations simultaneously. So I call that 1, call that 2. They're both equal to y, so I'm going to equate them. All right, equate 1 and 2, so you get x squared equals 3x minus p plus 1. All right, write that as a quadratic on the next line. So x squared minus 3x plus p minus 1 equals 0. Be careful when you bring your terms over. Don't make any mistakes with your signs because then the rest is wrong. Okay, you're just wasting your time then. All right, so we have now a quadratic where a is 1, b is minus 3, and c is p minus 1. Okay? All right, let's find the discriminant. Discriminant is b squared, which is minus 3 squared, minus 4 times 1 times p minus 1. Okay? And you get minus 3 squared is 9, and then minus 4 times 1 is minus 4, bracket p minus 1. Okay, so we get 9 minus 4p plus 4 when we do this expansion, and we get 9 plus 4 is 13 minus 4p. All right, now what did we say up here? That if it's a tangent, if this line is a tangent to this parabola, the discriminant must equal 0. So let's make the discriminant equal to 0. Okay, so therefore this here, which is the discriminant, okay, is equal to 0. And solve for that. Solve for p. So you get 4p equals 13, and therefore p is equal to 13 over 4, which is equal to 4 into 13 goes 3 times, remainder 1, so 3 1/4. And that is that.